All right, science nerds, here's your quantum field theory, fact of the day. And this one's a sneaky brain bender. Let's talk about something called dangerously irrelevant operators. Yeah, I know. Sounds like your ex, but no, this is real physics. In the renormalization group, or RG framework, we classify operators based on how their influence changes with scale. Like what happens when you zoom in or out on a system. Here's the cheat sheet. Relevant operators? These guys grow stronger at large scales. They dominate the behavior. Irrelevant operators? They fade away. We usually ignore them in the long-distance picture. Marginal operators, they're on the fence. Might matter, might not, depends on the details. But here's where it gets spicy. There's a sneaky type, called the dangerously irrelevant operator. Sounds like an oxymoron, right? But listen up. These operators have couplings that shrink under RG flow, so by all accounts they should be irrelevant, but they still have a massive impact on physical observables, especially near critical points. Here's an example that shows how wild this gets. Imagine you're looking at the magnetization near a phase transition in the classic 5-4 theory above 4 dimensions. The quartic coupling U0 is technically irrelevant here. Cool, right? Just toss it? Nope. Because the magnetization behaves like this. So as U0 gets small, the magnetization blows up. That tiny irrelevant coupling is in the denominator, and suddenly it's calling the shots. This is what we mean by dangerously irrelevant. It's irrelevant in theory, but in practice, if you ignore it, your predictions fall apart. Implications, you can get scaling violations. The usual rules connecting exponents and dimensions don't hold. It can change universality classes, so the critical behavior is totally different. And if you're building a theory near critical points, you better include these operators or you're in for a bad time. So remember, just because an operator fades under RG flow doesn't mean it's harmless. Sometimes the tiniest terms have the biggest bite. That's your physics drop of the day. Stay dangerously informed, friends.